when will you people be free tomorrow? Because I have to plan the session tomorrow again, accordingly as per your availability. So when are you people free tomorrow, guys? అరే మాట్లాడండి రా బాబు. Afternoon. Afternoon you are free. Morning what do you have? Morning do you have exam or what? Sir, we have AITS in the afternoon. Who has AITS in the afternoon? All of you have AITS in the afternoon? Do everyone have AITS? We'll extend the class till 10:30, guys. I don't know. I fell asleep. Right. So suddenly I woke up. Hey, what happened? There was no call also, sir. We are already. Please ask us to. Please allow us to enter the session. No call, no message, nothing. I think you all are also sleeping along with me. Huh? So can anyone tell me when you are free? In afternoon, are you free, guys? AITS. Who is writing AITS here? Because tomorrow we have to complete two chapters, gravitation as well as unit measurement. मॉर्निंग क्या है यार? मॉर्निंग क्लास रखना है या आफ्टरनून क्लास रखना है? क्या है?
Morning, if it was possible.
मॉर्निंग यू वांट क्लास? Right from 10:30 onwards, already an exam has been shared, guys, with you people. Work energy, power, and system of particles. It is valid from 10:30 p.m. to 10:30 a.m. tomorrow. Right, 12-hour validity of the test. Is the board visible, everyone? Is the board visible, all of you? Yes or no? Right. So let us see some questions of system of particles and rotational motion. Right. So whatever, how many other questions we can complete, we will try to complete. It's a very important chapter again, as I said. System of particles, gravitation, units and measurement. These three are very important chapters. There's a possibility of maybe around 8 questions, a maximum from these chapters that can be asked again. Right. 7 to 8, I can say. The where must a cue hit a billiard ball so that it rolls without slipping from start if r is the radius of the ball, they are saying. If it is rolling without slipping, right, what they are saying, where should we hit the cue ball, guys? So basically for pure rolling, again we know friction value will be given as f into h by r minus of k square by r square divided by 1 plus k square by r square. So in order for the billiard ball to perform pure rolling, right here, h by r value should be equal to k square divided by r square, guys. Right. So h by r value will be, what is k square by r square? Because billiard ball, if you take it is a solid sphere, so you are going to get it as 2 by 5, guys. So what will h value be? It will be 2r divided by 5. And what is h? Is it the distance from the center or not, guys? Yes, it happens to be distance from the center. So whenever we are hitting it, we are applying a force at a height 2r by 5 from the center, then we can consider that the cue ball, that the billiard ball is going to roll without slipping, guys. Clear, everyone? A hollow sphere of speed 12 kg rotates about its axis with angular speed 50 radian per second. Hollow sphere is given, omega is given, radius of the hollow sphere is 0.25. The kinetic energy associated with only rotation they are asking, guys. So in this situation, what is rotational kinetic energy? As we all know, it is given as half I omega square. For a hollow sphere, guys, what is moment of inertia? You will get it as 2 by 3 mr square into omega square. So the rotational kinetic energy or kinetic energy associated with rotation will be given as 1 by 3 mr square into omega square, guys. So what are we going to get? This will be 1 by 3. Mass is given as 12. Radius is given as how much, guys? I think it's given as 0.25, which can be taken as 1 by 4 whole square, right? Omega value is already given in radian per second, whole square you can consider. So what are we going to get? 3 ones, 3, 4 we are going to get. 1, 4 and 4 will get cancelled out. So this will turn around 2500 divided by 4, guys. So the rotational kinetic energy, if we consider, it will be 625 joules. Clear, all of you? Understood, everyone? Rotational kinetic energy is half I omega square. If they ask you to find the total kinetic energy, because you know rotational kinetic energy, the total kinetic energy can be taken as rotational kinetic energy into 1 plus r square divided by k square, guys. Okay, so you can find by using this particular formula. I hope it is clear, everyone. Yes or no? Let us talk about the other question. So they are saying that a uniform sphere of mass m and radius r rolls without slipping down an inclined plane, inclined at an angle 53 degrees with the horizontal. What is the minimum value of coefficient of friction at which slipping is absent? Slipping is absent means it is performing pure rolling. What is the minimum value of coefficient of friction, beta? I think this also we have seen, it is given as tan theta divided by 1 plus r square divided by k square, guys. So minimum value of coefficient of friction, if I take, you will get it as tan 53. Uniform sphere is given. Uniform sphere means you can consider it to be a solid sphere, guys. So r square by k square value will be 5 by 2, guys. K square by r square is 2 by 5. R square by k square for solid sphere will be 5 by 2, guys. So this will be 7 by 2. So I can write it as 2 by 7 times of tan 53 is how much again? Tan 53 happens to be 4 divided by 3, guys. So you will get it as near about 8 divided by 21. So the coefficient of friction value should be 8 divided by 21 for a uniform sphere which is placed on a inclined plane of inclination 53 degrees in order to perform pure rolling, guys. I hope it is clear, everyone. What is the question given over here? Next question, if you see, a disk of mass m and radius r is rolling without slipping. Velocity of point p will be how much they are asking, guys. Again, one of the good question, right? If they are asking us to find velocity of point p, what are we going to do? Again, due to the effect of translation, if I consider, guys, whenever an object is performing translation with speed v, will every point move with the same speed or not, guys? So you can consider this point to be o. Where is the point p, beta? It is at a distance, as you can see, it is at a distance r by 2. Now because the entire object is translating with speed v, every point on that or on that object will be performing translation with speed v. Now it is performing angular speed, the sense of which is how much, beta? Clockwise. So whenever it is performing rotation about center with angular speed omega, then what is going to happen? This is due to the effect of translation, guys. What is the rotation effect here? Now along the sense of rotation at the given point, you just need to draw a tangent again. So at the given point, so you can consider this is the effect of your rotation. And at what distance is the given point from the axis of rotation? It is at a distance r by 2 into omega. Always remember, whenever an object is rotating, every point on that object is going to rotate with same angular speed. But what will be different, beta? Linear speed is going to be different again. So if you look at point P, due to the effect of translation, it has speed v along positive x direction. Due to the effect of rotation, it has speed r by 2 into omega also along positive x direction. So from this, what we can tell about the speed of point p, beta? Because both are in same direction, I can write v plus r by 2 into omega. So what is the velocity of point p? They are saying it is rolling without slipping, has been mentioned, guys, on a fixed surface. So rolling without slipping on a fixed surface means I can consider v and r omega to be equal, guys. So what we can write this as? We can write it as v plus or anyhow it is given in terms of omega, guys. So we can write v value as r omega plus r omega over 2. The speed of point P, you can take it as 3r omega divided by 2. Clear, everyone? Is that clear? Is also direct question again. 3r omega divided by 2 will be the speed of point P, guys. Whenever object translates, every point on that object will translate with the same speed, guys. When object is rotating, every point on the object will rotate with the same angular speed, but the linear speed due to the effect of rotation for different points will be different. And how will you take beta? That will always act perpendicular to the line joining the axis of rotation and the given point, guys. See, as you can see, this is the effect of rotation. How is it acting? It is acting perpendicular to the line joining axis of rotation and the given point. It's a very important case again. I hope it is clear, all of you. Yes or no? Then a hoop of radius r weighs m kgs. It rolls along a horizontal surface so that the center of mass has speed v meter per second. How much work has to be done to stop it? When it is stopped, again here we will be using work energy theorem in rolling, guys. So what is the situation? Here work done should be equal to change in kinetic energy of the system, guys. So here work should be done both in translation as well as in rotation. So hoop of radius r weighs mass m kg, right? It rolls along a horizontal surface so that center of mass has speed v meter per second. How much work has to be done to stop it, they are saying. The work done should be change in kinetic energy of the system. What we can write, the work done should be final minus initial kinetic energy. Finally we are stopping it, so automatically I can say final kinetic energy will be 0. Now, how can I write initial kinetic energy as beta? Initial kinetic energy, speed is given, so means we can find out translational kinetic energy. So I can write it as half mv square into 1 plus k square divided by r square, guys. So what will I get work done as? You will get this as minus half mv square. Hoop is given. So hoop is nothing but you can consider in the form of a disk, guys, again. Okay. So what we can take 1 plus k square by r square value. How much is it going to be? You will get it as 1 by 2 again. Yes or no, everyone? The hoop of radius r weighs m kg. It rolls along a horizontal surface so that center of mass has speed v meter per second. How much work has to be done to stop it? They are asking, guys. So what will this be? I think it is considered to be as ring only. So you can take k square by r square value as 1. So you'll get this as minus half mv square into 2. You will get the work done should be minus mv square. So here how much work has to be done? So minus means work is being done on the object, guys, on the hoop. So mv square amount of work has to be done in order to stop that particular hoop, guys, which is rolling, right? So here we will take not only translational kinetic energy, but we will also consider rotational kinetic energy. So total energy will in rolling will be given as translational kinetic energy into 1 plus k square by r square. Clear, everyone? A boy standing on a rotating table with heavy spears in his hand suddenly brings his hands close to his body, guys. Now here everything deals with moment of inertia again. So basically we have seen moment of inertia for point masses will be given as mass times of square of the distance from the axis of rotation, right? So a boy is rotating on the table, initially is rotating like this. So spears are placed on his hands, guys. So now as you can see, the masses are away from the axis of rotation. You can take it something like this. So he is rotating in a turntable. Let us imagine this is the person, right? So what he is doing, he is holding the spears somewhere over here. Okay. Now masses are away, means moment of inertia will be more, guys. What he is doing now, he's trying to bring these spears closer to him, guys. So he's bringing the spears closer to him again. So what he has done, he brought it something like this, let us say. Okay, he brought them something in this manner. Now you see what has happened to moment of inertia. Moment of inertia value will reduce because what is the situation here? Masses came near to the axis of rotation. So it was rotating with angular speed omega initially. This will be omega dash, guys. So here in first case, let us imagine in this case moment of inertia is I. In this case, moment of inertia is I dash. In such case, angular momentum will remain conserved. Here, the object is simply rotating, guys. It's not sliding. So there is only rotation in this case. Due to the effect of rotation, we are going to have only one angular momentum called as spin angular momentum. So in first case, what is it? I into omega. In second case, what is it? I dash into omega dash. So omega dash value will be I divided by I dash into omega. So what is here? What we can tell regarding I dash value? Because the masses are now close to the axis of rotation, I dash value will be less than I. So I by I dash value will get it as less than 1, guys. So omega dash, what we can consider? I value will be greater. So I by I dash will be greater than 1. So here we can write omega dash will be greater than omega, guys. So what we can consider, angular speed is going to increase. Angular momentum anyhow will remain conserved, but what will happen to angular speed? It will be increasing, guys. As you can see, angular momentum of the system remains same is correct. Angular velocity of the system decreases is wrong, guys. Angular momentum of the system increases is wrong, right? So what would be the correct statement? Only first statement would be the correct statement. Clear, all of you? When the spheres are away, masses are away from the axis of rotation. And how do we give moment of inertia? Basically, it is given as sigma I is equal to 1 to n mi into ri square. R is the distance of the mass from the axis of rotation. If the masses are away from the axis of rotation, moment of inertia will be more. So as the masses have been brought nearer, guys, right, R value will reduce, moment of inertia will reduce. If moment of inertia is reducing, omega value should increase. Clear, everyone? Yes or no? Let us see the next question, guys. 484 joules of energy spent in increasing the speed, okay, of wheel from 60 rpm to 360 rpm. Moment of inertia of the wheel they are asking, guys. So what is given here? We are increasing the angular speed. So here work done they are saying. So how much work, how much is of energy is spent? 484 joules. So can I say this much of work is done? This much of work is done in order to increase the speed from 60 revolution per minute to 360 revolution per minute, guys. So we need to convert this into radian per second. They're asking us to calculate what is the moment of inertia. So what we can use in this situation, we can write the rotational kinetic energy value can be given as half I, or you can basically use work done will be, here work done is only in rotation, guys. So it will be change in rotational kinetic energy, guys. It will be change in rotational kinetic energy. The final rotational kinetic energy minus initial rotational kinetic energy. So I can write half I omega final square minus half I omega initial square, guys, which I can also write it as half I into omega final square minus omega initial square, guys. So what are we going to get? The value of I as here, you can take it as 2w divided by omega final square minus omega initial square, which can be taken as 2 into 484 divided by omega final is given as 360. 360 revolution per minute is given. So I can write into 2 pi divided by 60, right? Minus of omega initial is given as 60, guys. So 60 into, again I can write 2 pi divided by 60 whole square. So what we can cancel out? 60 and 60. 60 and how much? 6. So 12 pi you will get. So I can take it as, we can consider this to be as 2 into 484 divided by, right, 12 pi, 12 pi whole square, you can take it as 144 pi square beta, minus you can take this as 4 pi square. Yes or no? So I'll get it as 2 into 484 divided by, how much will this be? 140 pi square you will get. Yes or no? So 2 ones and 2, how much I will get? 70 you are going to get. Pi square value you can take it as approximately 10, guys. So I'm going to get this value, the moment of inertia, as 484 divided by 700 you can take, which can also be written as 4.84 divided by 7, which will be near about zero point 0.7 you will get. Zero point 0.6 is 42, then you will get 64 to 769 you will get, guys. Kg meter square you can consider. So this much will be the value of moment of inertia again, which is approximately zero point 0.7, guys. So 0.69 kg meter square will be the value of moment of inertia. Clear, everyone? So here work energy theorem in rotation we are considering, guys. Work done in rotation will be change in rotational kinetic energy, guys. Same manner, in case of your translation, work done will be change in translation kinetic energy. In case of rolling, work done can be given as change in total kinetic energy, which is sum of translation kinetic energy as well as rotational kinetic energy. I hope it is clear, everyone. Yes or no? Doubt?
Sir, could you explain that in the previous question? How
अरे
did you explain?
प्रीवियस हो गया, नेक्स्ट भी हो गया, अब नेक्स्ट में जा रहे हैं, तुम बोल रहे हो प्रीवियस क्वेश्चन में सर, बोलो. हाउ डिड,
Sir, why was the angular momentum remaining the same?
why is there any external force acting? The
Yeah,
entire system you say there is no force acting, means there is no torque. If there is no torque, what will be conserved? Angular momentum will remain
angular momentum.
conserved. Clear? Yes or no, yaar?
Yes, sir.
Let us talk about the next question, guys. Hollow sphere of radius 0.5 meters and mass 10 kg rolls on a horizontal surface. Its center of mass has speed 60 centimeter per second. Magnitude of work required to stop it. It is similar just now we have done or not? In the previous case, was it solid sphere? Yes or no? So what is the work done here? Again, final kinetic energy minus initial kinetic energy. Finally, it will be zero. Initially, it should be written in terms of. Uh, we have discussed this question, so I'm not discussing it again, guys. Clear, everyone? Can you solve for this question, all of you? Again, we are going to use work energy theorem only. Work done will be change in kinetic energy of the system, which is final kinetic energy minus initial kinetic energy. What is final kinetic energy? Because I have to stop it, it is zero again. So what will be your work done, beta? Minus of what is initial kinetic energy? I can write it as half mv square into 1 plus k square divided by, because speed is given. You can solve for this, you will get the answer, and you have written everything. So it will be minus of what is the mass given here, beta? 10 kg. What is the speed? 60 centimeter per second is given. It means it is zero point 0.6, beta. Zero point 0.6 can be written as 6 by 10. So 6 by 10 whole square you can write. And what is the value of k square by r square for hollow sphere? It is 2 by 3, guys. So what will I get here? 36 by 10 you will get. 36 by 20 you will get, guys. So it turns out to be 36 divided by 20, and this will be 5 divided by 3. 5 ones, 5 fourths. I think you will get it as 3 joules, guys. Clear, everyone? 9 by 5 you will get. 5 and 5 will get cancelled out. 3 joules will be the answer for that. I hope it is clear, everyone. Good question again. If you do questions repeatedly, then obviously you'll have the idea of solving the question, guys. A solid sphere is rotating freely about its axis of symmetry in free space. The radius of sphere starts decreasing, keeping its mass same. What will happen? They are asking. Will angular momentum remain constant, guys? Again, yes. So as radius decreases, what will happen to moment of inertia? Moment of inertia decreases. Why? Moment of inertia is given as 2 by 5 mr square. In keeping mass constant, radius is decreasing. So automatically, moment of inertia will reduce. What should remain same? Angular momentum should remain same. If I is getting reduced, what should happen to omega? Omega value should increase, guys. So angular speed will increase, angular momentum will remain constant, guys. Rotational kinetic energy will increase, it seems. So what we can write regarding rotational kinetic energy? Can I write it as L square divided by 2I or not? Which is half I omega square. I can write L square divided by 2I. So I value is decreasing, L is constant. What is angular momentum here? Angular momentum is constant. And what is happening to the moment of inertia? Moment of inertia is decreasing. So automatically what will happen to rotational kinetic energy? It will be increasing. Rotational kinetic energy will increase, angular speed will increase, angular momentum will remain constant, guys. Understood, everyone? Yes or no? Let's talk about the next question. Very important question. We have done center of mass, guys. In whichever manner we have found out center of mass, in the same manner, center of mass for removed portions, whatever concept we have applied, in the same manner, we are also going to find moment of inertia for removed portion, guys. What they are saying is from a disk of radius r and mass m, a circular hole of radius r by 4 is removed from a distance 3r by 4 from the center. Okay, the moment of inertia of remaining part of the disk about the axis perpendicular to the plane and passing through the center of the original disk, they are saying, guys. So if I take, the question will be something in this manner. From the center, this total distance from here till here is r. Yes or no? So what they are saying, uh, a whole of radius r by 4 is removed from a distance 3r by 4 from the center. So if I take 3r by 4 from the center, guys, so this would be the center again. This will be anyhow automatically r by 4. So if I take one more, so you will get it something in this manner, guys. You will get it something like this. So what is left out now? As you can see, this part is left out, guys. So they're asking us what is the moment of inertia of this particular disk which is left out. About which axis, beta? About an axis passing through the center. About this axis, they're asking us to calculate. Now what I'll do? First, I'll take two disks again. So what are the disks? What is the total moment of inertia now? Here I'll write I1 plus I2. I1 is for the larger disk, or we can take I of larger disk plus I of smaller disk, guys. Always moment of inertia, because it is scalar value, you will be doing it in this manner only, guys. From a disk of radius r and mass m, a circular hole of radius r by 4 is removed from a distance 3r by 4 from center. The moment of inertia of the remaining part of the disk about an axis passing through the center of the original disk and perpendicular to the plane, they are saying. So this is lying in xy plane. They're asking about z axis, guys. So for the large disk, if I consider, right, for the large disk, what will be moment of inertia about an axis passing through center? So I can write it as mr square divided by 2 plus. Now smaller disk is being removed, guys. So what I'll do, minus. Let us imagine this smaller disk has a mass of m dash, guys. Automatically its radius will be r by 4 or not. So what is moment of inertia for the smaller disk about this axis? I'll apply parallel axis theorem. What I'll do, I'll take this axis. One axis is passing through O dash, other axis is passing through O. So we have two parallel axes, one of which is passing through center of mass of the smaller disk. So what will be moment of inertia about this axis? Sum of moment of inertia about an axis passing through center of mass and product of mass and square of the distance, guys. So what we can tell here, because it is being removed, I have written minus. What is moment of inertia about this axis? We can write it as m dash into, what is the radius? R by 4 whole square divided by 2 plus m dash into, what is the distance between the two axes, beta? It is given as 3r divided by 4 whole square. This is how you will calculate moment of inertia for a smaller disk about point O, guys. About point O for larger disk, directly against it is mr square by 2. But what will it be for smaller disk again? For smaller disk, guys, in order to find moment of inertia about this axis, I'm going to make use of parallel axis theorem. It will be moment of inertia about O dash plus m dash into square of the distance between O and O dash, guys. I hope it is clear, everyone. Yes or no? Right. Now, what will you do? You can write it as mr square divided by 2 minus, what will this value be? I will get it as m dash into r square divided by 32 I will get, minus I'm going to get it as 9 m dash r square divided by 16 I'm going to get. So if I find out the LCM over here, guys, so what are we obtaining in this situation? So I'll get it as mr square divided by 2 minus of 16 will be the LCM. So you will get 1 minus 9, guys. Sorry, 1 minus 18 you will get, I guess. Did I read correctly only, guys? I hope so. So what we can take here? I think you will get it as minus 17 m dash into r square divided by 32, guys. Right? So from this, if I take r square by 2 common again, so or if you take the LCM, guys, right? So you'll get it as 16 mr square, right? Minus 17 m dash into r square divided by 32. Now, how do you find m dash value? Very simple logic. The whole mass m is distributed in an area pi r square. M dash mass beta, it is distributed in area pi into r by 4 whole square. So we are simply going to perform crisscross again, guys. What are we going to perform? We'll simply perform crisscross over here. So what are we going to obtain in this situation? We can take it something like this. So m into this will be pi r square by 16 should be equal to m dash into pi r square. So what is our m dash value, guys? Here you can write m dash value as m dash value will be m by 16, guys. Okay. So what will I get? 16 mr square minus, so m dash will be, I can write it as 17 divided by 16 into m r square divided by 32. So I can take mr square divided by 32 common. What I will be left out? In this you will be left out with 16 minus 17 divided by 16. So what is 256 minus 17, guys? 256 minus 17. How much will I get? 16 square is 256 only, no? 256 minus 17, how much will you get? Is it 239? Yes or no? Did I do any mistake? Just check. Why did I take minus sign here, guys? This is plus, no? Here also you'll get plus. Sorry. Here you should get plus. So if you take LCM, I think you'll get this as 19, I believe. Am I right? 18. This will be 19, guys. Here you'll anyhow take minus only. This is 19 again. This is 19 and 19. And write this as 19 by 16. Okay. So you'll get 256 minus 19 again. So if you do 20, you will, so it is 237, guys. So I'll get this as 237 mr square divided by 32 into 16. 256 into 2 will be 512, guys. This will be the moment of inertia. 237 divided by 512 mr square. Very important case, guys. So if they're asking you to find moment of inertia about any particular point, what are we going to do? It will be moment of inertia, sum of moment of inertia for all the objects given in the system about that particular axis, guys. That is what we have done in this situation. So they were asking us to find moment of inertia about point O. What I have done, I have just added moment of inertia due to the larger disk as well as moment of inertia for the smaller disk. Now, because smaller disk is being removed, I just used minus sign. So why did I write minus sign here? Because smaller disk is being removed, guys. Clear? Very important way to calculate moment of inertia. Definitely moment of inertia, energy in rolling, rolling on a inclined surface. These questions are very, very important. Angular momentum questions. From neat point of view, they are very important, guys. I hope it is clear, all of you. Yes or no? Let us see the next question, guys. What they have given. A point mass moves in a circle of radius r with speed v on a smooth horizontal table with the help of a string whose other end passes through a hole. By pulling the string, the radius of the circle is reduced to 2r by 3. What is happening to the final angular momentum they are saying, guys? Okay, so very simple logic. Angular momentum though will remain constant. So initially, if you see, a point mass moves in a circle of radius r with speed v on a smooth horizontal table. So instead of showing in horizontal way, guys, so initially you can consider it is performing circular motion on a horizontal table. So I'll just take it like this, guys. So initially it is performing in this manner. Okay, it is performing something like this with the help of a string again. So you can assume it is placed like this beta. It is placed on a horizontal table. It is rotating on a horizontal table. So because it is rotating, at how much distance? The distance of the length of the string is nothing but r. So how will you find the speed, guys? Suppose if I imagine the sense of rotation is clockwise, so how will I find the speed? Along the sense of rotation at the given point. I'm just going to draw a tangent. Clear, all of you? Right. Now what has happened? Right? A point mass small m moves in a circle of radius r with speed v on a smooth horizontal table with the help of a string whose other end passes through a hole. Let us say this is the hole. It is passing through the hole. Now by pulling the string, the radius is reduced to 2r by 3. What is the final angular momentum of the system they're asking, guys? So what is initial angular momentum here? Because we have only translation. If velocity is there, means obviously what will you have? Momentum, linear momentum will be there. So I want to find angular momentum about point 0, guys. So what will be our angular momentum about point 0? If you want to find angular momentum about point 0, what will we do? We'll consider an axis passing through point 0 and perpendicular to the plane. So axis is passing through which point? Through point O. This is the line of action of linear momentum, guys. Yes or no? You take anywhere, there will always be separation. And what is that separation? It is r, guys. In which direction? J cap you can take. At this instant, I am finding cross m into v I cap you are going to get, which will be m v r j cross I. You know it is minus k cap. So in this situation, what will be conserved? Angular momentum will remain conserved. So initially it is mvr. Even when you are, so if you bring this mass closer, guys, what will happen to moment of inertia? It will reduce because initially the mass is present at a distance r from the axis of rotation. Now that same mass came near by a distance r by 3. So what is happening to moment of inertia? Moment of inertia will decrease. Angular speed will increase, ensuring that the angular momentum of the system will remain conserved. So our answer should be MVR itself. Clear, everyone? Yes or no? Initially or finally, it will remain MVR only, guys. So finally, what would be the situation going to become? You can consider finally the situation becomes something like this. So what will be the distance now? If you talk about the distance, now the distance will be 2r by 3. And again, sense of rotation is not going to change. Sense will be clockwise only, but what will change, beta? Linear speed is going to change. Linear speed, angular speed, these are going to change again. So let us say sense is clockwise only. So what is the distance again? 2r by 3 is the distance. So what will happen to speed? Speed will become v dash, guys. Is that clear, everyone? So what will happen to the speed? Speed is going to become v dash. So same, angular momentum will remain conserved over here. Any doubt in this, all of you? Angular momentum of the system will remain conserved. So initially if it is MVR, finally also it will be MVR only. So in first case, moment of inertia may be given as mr square. So here in this case, if they're asking moment of inertia directly, I can write m into distance from the axis of rotation will be r. Here what will be moment of inertia, beta? Mass is m, but distance you can write it as 2r by 3 whole square. So what is I dash value? It will become 4mr square divided by 9. So what has happened here? I dash value is less than I. So implies omega dash value will be more than omega. I can write v dash value will be more than v. But L dash and L both will be same. Angular momentum will remain conserved in this situation. Clear, all of you? I hope it is clear. Let us see the next question, guys. Three identical uniform spheres, each of mass m and radius r, are placed as shown. The moment of inertia of the system about the axis is how much they are asking, guys. So what I'll do, very important case, we will just name them as first sphere, second sphere, as well as third sphere. Okay. Now, what we will be taking? I need to find moment of inertia about this axis. So moment of inertia about given axis will be sum of moment of inertias for all the masses about the same axis, guys. So what I'll also do, I will consider a parallel axis passing through the center of masses, guys. We are considering parallel axis passing through center of masses. So we need to find the perpendicular distance. This distance I need to find. Okay. So always remember, if I take the same situation from here to here, this will be 2r. From here to here, this will also be 2r. From here to here, this will also be 2r. So it will be an equilateral triangle, and this will be height of the equilateral triangle, guys. So what is moment of inertia for first sphere about the given axis? The given axis is an axis passing through its center, means nothing but diameter, guys. So what is moment of inertia for first sphere? Because it is identical, it is solid sphere, you can write it as 2 by 5 r square. Whereas for second sphere and third sphere, moment of inertia will be same. That is the reason I'll write it as 2 times of what will be moment of inertia for either second or third sphere? Sum of moment of inertia about a parallel axis passing through center of mass. How much is this? 2 by 5 mr square plus m into what is the distance here, beta? You can write it as h square. And what is h? It is the height of this particular equilateral triangle whose side length is 2r. So I can write it as 2 by 5 mr square plus 2 into, this will be again 2 by 5 mr square plus m into what is height of an equilateral triangle? I think you all are aware. It is root 3 by 2 into a, guys. Here side is 2r. Clear, everyone? Very important case again. Very important question also, guys. What we can write this as? This can be taken as 2 by 5 mr square, right? Plus 2 into, this turns out to be 2 by 5 mr square. And if you solve for this, you will get this as uh, root 3 by 2. So 2 and 2 will get cancelled. Root 3 r whole square you will get, which is 3r square, guys. So I can write it as 3 mr square. So what will it turn out to be? 18, 15, 17 by 5 you will get. 34 by 5 you will get. I think overall you will get it as 36 by 5 mr square. Is that clear, everyone? It's a very important question. Similar type of question has been asked in once in previous year questions, guys. Similar type of question again. I cannot say exactly same question, but the axis was given something like this. Okay. So here they have given axis in this manner. The axis was given in this manner. So if the axis was given like this, guys, this axis is diameter for one of the sphere and tangent for the other two spheres, guys. So in that case, I'll get moment of inertia as for this 2 by 5 r square, for this 7 by 5, for this also 7 by 5. So overall answer will be 2 by 5 plus 7 by 5 plus 7 by 5, 16 by 5 r square about this axis, guys. But they have asked about AB. So about AB, you will get it as 36 by 5 r square. Clear, everyone? So or no? I hope it is clear, all of you. Let us see the next question, guys. Hmm. Yes, Harshit.
Sir, in the diagram, why didn't we take
అరే
x is
ఎట్లా
equals to
తీసుకుంటారా 2r ఎట్లా తీసుకుంటా చెప్పు నువ్వు
the perpendicular distance?
పర్పెండిక్యులర్ డిస్టెన్సా చూడు
Yes, sir.
చూద్దాం పర్పెండిక్యులర్ డిస్టెన్స్ అంటున్నావు కదా ఇగో ఇక్కడ నుంచి ఇక్కడ దాకా ఎంత ఆర్ ఓకే
R.
మళ్ళీ ఇప్పుడు నేను ఇక్కడి నుంచి ఈ డిస్టెన్స్ తీసుకోవాలి ఈ డిస్టెన్స్ నుంచి ఈ డిస్టెన్స్ ఆరా
No, sir.
తీసుకోవచ్చా 2r
Okay.
క్లియర్
Yes.
let us see the next question, guys. A man of mass 50 kg is in gravity free space at a height of 20 meters above the floor. He throws a stone of 0.5 kg downwards with a speed of 36 km per hour at an angle of 60 degrees with vertical. When the stone reaches the floor, the distance of man from the floor. So he is a man of 50 kg is in gravity free space. Okay, at a height of 20 meters. So there's no gravity acting here, guys. He throws a stone of 0.5 kg downwards. So how is he throwing a stone, guys? Making an angle 60 degrees with the vertical, it seems. You can imagine this fellow is throwing a stone in this manner. Okay, right. In this manner, he is throwing by making angle how much? 60 degrees with vertical. Right, you can imagine he's throwing a stone. Mass of the man, you can take it as capital M. Mass of the stone, you can take it as small m. He's throwing with what speed, beta? 36 kilometer per hour means into 5 by 18. If you do, it will be 10 meter per second. Now, what I'll do is I'll just resolve the velocity, guys. So you can take it something in this manner. So here, what are we going to get? So it is moving with some speed. It has been projected with some speed u, or 36 kilometer per hour is given. If I convert into meter per second, I'll get it as 10 meter per second at an angle 60 degrees, guys. Now I'll resolve into two components. If I resolve into two components, what are we going to get? This will be one of the component, this will be the other component. Right. So what will this component be? This will be 10 sine 60. And the other one will be 10 cos 60. Now 10 cos 60 is 1 by 2. This will be 5 meter per second. And 10 sine 60 is root 3 by 2. You will get it as 5 root 3 meter per second. Now please tell me, when the stone reaches the floor, stone has two components. This is one of the component, other is this component, guys. Which out of these two components will help the stone reach the floor? At t is equal to 0, let us say. Right, which component will make it reach the floor? So obviously this particular stone, right? So this you can take it as 10 meter per second. Because it is gravity free space, it will move in a straight line only, guys. It will move in a straight line only. And it is going to hit the floor. So which component will make the stone hit the floor, guys? Which component? Will this component make the stone hit the floor? No. Because of this component, the stone will continue to move along x direction. So which component is helping it to hit the floor? 5 meter per second, guys. So what is the time that I am going to get? So height is given as 20 meters. So what is the time after which it is going to hit the floor? You can say, in order to hit the floor, it has to cover a vertical displacement of 20 divided by what we can write? 5. So what will you get? 4 seconds you are going to get, guys. Yes or no? Now they are asking the distance of the man from the floor is how much? Okay. Now what we can do here is, right, initially man is just standing, let us say in gravity free space. What he has, initial momentum will be 0 because he has not thrown the stone, let us say. Stone is at rest in his hands, man is also at rest. So both of them are at rest. So initial momentum is 0. Now when he is throwing, it is an internal to the system, guys. Right. So internal forces are acting. Right. However, will external force act to change the motion? No. So what we can conserve? Linear momentum will remain conserved, guys. So I got momentum in this particular direction. So in order to cancel out this momentum, how will man move now, guys? So if I take the case of the man here, should momentum be conserved or not? Why? Because there is no external force. So if I take the case of the man, so what will happen here, beta? So small m is the mass. Again, you can give. So in order to cancel out the momentum in this direction, so automatically can I say the man should be moving something in this manner or not? We can consider man to move in this manner with some speed v. Now at what angle? This angle should be 60. With vertical again, he should make 60 degrees, guys. So what we can conserve? We can conserve the linear momentum. So small m into u, assume that this is u, guys, should be equal to capital M into v. Momentum should remain conserved again. Okay, so this momentum has to be cancelled out. So I'll get v value as small m divided by capital M into u. Small m value is how much, beta? 0.5 kg. You can take it as 1 by 2. Capital M is given as 50. U we got it as 10. So I'll get it as 0.1 meter per second or not? Yes or no, beta? 1 by 100. This will be zero point 0.1 meter per second. Okay, so V value we got it as how much now? 0.1 meter per second. Can I resolve into two components? Certainly you can resolve into two components. So if I resolve into two components, I'll get this component as how much, beta? 0.1 sine 60. Yes or no? And what are we going to get this component as? You will get it as zero point 0.1 cos 60. Yes or no? Now they're asking us to find distance of the man from the floor. So how much height will it cover? Right, the height it has covered in 4 seconds. Zero point 0.1 cos 60 will be anyhow 0.1 by 2 is the speed. Right, this component, will it make the man move higher, guys? No. This component will give only displacement along positive x direction. However, which component is taking the man above the floor? Zero point 0.1 cos 60. In 4 seconds, how much will it take? I can write it as, this will take it as 0.2 meters, guys. So already it is at 20 meters. Now what will be the distance from the, you can consider from the floor, guys? 20 meters, as well as in 4 seconds, 0.2 meters. So now it will be at a distance 20.2 meters, guys. Clear all of you? Very good question, you see. Sir, how to solve such kind of question? How to so just by reading the question I cannot solve this question. Why you cannot solve? Because you're not allowing your mind to think what is the situation happening, right? Once you start allowing, then automatically everything will flow, guys. It will flow again, right? Without your intentional efforts also, your mind will just flow and say that, Arey, you have to do this thing, you have to do this thing, you have to do this thing. I have not solved this question before. I'm doing it with you people only. Right. So the reason is, it's very simple, guys. You keep your fundamentals thorough. What did we do? Did I do anything here? Gravity is not there. So did I make use of gravity? No. I'm just using distance is speed into time, guys. Right. So there is no external force. Whenever there is no external force, momentum has to remain conserved. So initially momentum is zero. Finally also momentum should be zero. But stone has been given momentum in this direction. In order to cancel out this momentum, man has to move in this manner, exactly in opposite direction. So I've conserved the linear momentum, found out the speed. Now I have also found out which component will help the stone to hit the floor and which component will help the man to rise up. So using these two, I have found out the time after which the stone hits the ground. In this much time, how much is the rise in the height of the man or rise in the man? We got 0.2 meters. Clear all of you? This is how we will solve the questions, guys. Understood, everyone? Let us see the next case, guys. Now, always remember, moment of inertia whenever you are trying to calculate about any axis, guys. It will be least about an axis passing through center of mass, guys. Right? Moment of inertia for any object you take, it will be minimum about an axis passing through center of mass and lying in the plane, guys. Because perpendicular to the plane will obviously be more than lying in the plane. The moment of inertia of a uniform triangular lamina of uniform mass density will be all three axes lie in the plane of the lamina, guys. Now, if I assume, right, if I take the lengths are same, guys, so this will be how much? Let us imagine this length is L. Let us also imagine this length is L, beta. If I say lengths are same, moment of inertia of a uniform, they have said. Uniform means obviously it is going to remain same. Yes or no? Then we have this particular axis. Now, please tell me about first axis, guys. What is moment of inertia? First, I'll tell you about first axis. This axis I have taken. Which side? What is the length perpendicular to this axis, guys? Is L the length perpendicular or not? So blindly I will write, if mass is m, m into the length which is perpendicular to the axis, ml square divided by 6. What will I2 value be, guys? Again, I2 value if I consider this one. Which length is perpendicular again? Again, L only is perpendicular, guys. So I can write ml square divided by 6. Okay. About third axis, Now, if I want to find about third axis, guys, how will you do about third axis again? Whenever we are considering third axis, the moment of inertia of a uniform triangular lamina of uniform mass density will be how much they are asking, right? Where will its center of mass lie? It will be somewhere over here. We can say at the centroid, right? Somewhere over here. So, is this axis going to be away from the center or not, guys? So, you will have moment of inertia somewhere over in this manner. You will have, this is the axis passing through the center of mass and lying in the plane, let us say. You take both first axis and second axis, they will be closer to the, because centroid divides the median in the ratio 2:1. From side, it will be one third of the height. Yes or no? So this distance and this distance are same. However, from vertex, it will be two-thirds of the height, guys. So about this axis, it is minimum. Now first axis and second axis, both are what, beta? Again, whether you take this axis or this axis, it will be same, guys. Now first axis and second axis, are they at same distance from the axis passing through center of mass? Yes. So what I can say here in this situation, guys, which axis is away from the center of mass? Third axis. So I3 value will be greater than I1 will be equal to I2, guys. So about which axis it is maximum? It is maximum about third axis, guys. Understood all of you? Always remember moment of inertia about an axis passing through center of mass and lying in the plane of the object will be minimum. Then I can apply parallel axis theorem. First axis and second axis will be equidistant from the axis passing through center of mass. But third axis will be at large distance. So if you apply parallel axis theorem, I3 value will be more compared to I1 and I2, guys. Understood all of you? Yes or no? Hope it is clear. Next question, let us see. They're saying a solid sphere of mass 2 kg rolls down a fixed inclined plane of height 7 meters. The rotational kinetic energy of the sphere at the bottom of the plane is how much? Right? We know the uh, speed, guys. So what is speed with which it is going to reach the center? It will be root over 2gh divided by 1 plus k square by r square. This we know. Can we find omega also or not? So what is omega? It is VCM divided by r. They're asking rotational kinetic energy. So we know it is half into I into omega square. For solid sphere, what is I value? 2 by 5 mr square. What is this value beta? Omega square, if I take it, is VCM square divided by r square. So we can cancel out r square and r square. 2 and 2. Mass is given as 2 kg again. So I'm going to get it as m by 5 into what is v square value? 2gh divided by 1 plus k square divided by r square, guys. So mass is 2. 2 divided by 5 into 2 into g value is 10. H value is how much? 7 meters divided by 1 plus what is k square by r square for solid sphere? Again, it is 2 by 5. Yes or no, everyone? So what are we going to get? This you can write it as, this can be written as 2 and 4 by 5 you will get, guys. So 40 by 5 into 7 divided by denominator, if I take, you will get 7 by 5 again. So overall our answer should be 40 joules beta. Clear, everyone? Next case, if you see a solid cylinder of mass 2 kg, solid cylinder of mass 2 kg is rolling on a horizontal surface with velocity 5 meter per second, collides with a horizontal spring of force constant 300. This is we have done in, if you remember, we have done similar type of question, right? Those who have written the exam, you got the question in the exam also, guys. And we have done this in work energy power. A cylinder, a solid cylinder, sorry, you will be writing in the exam similar type of question, I'm sorry. A solid cylinder of mass 2 kg is rolling on a horizontal surface, right? So as it strikes the spring, guys, what will happen? It will be compressed. So whatever loss in kinetic energy is there, how will you solve this question again? Loss in kinetic energy of the cylinder, total kinetic energy of the cylinder will be equal to gain in elastic potential energy of the spring, guys. Gain in elastic potential energy of the spring. What is the meaning of loss? It will be initial minus final. What is the meaning of gain? Final minus initial. When will you have maximum compression? When will you have maximum compression or maximum elongation? Right? When the final velocity becomes zero, guys. So final kinetic energy is zero. Initial potential energy is zero. What is initial kinetic energy? It is rolling. It is rolling, guys. So what I can write? I'll write it as half mv square into 1 plus k square divided by r square. And what is the final potential energy? You can write it as half k x max square, beta. So what is the speed? Already speed is given to us. How much is it? 3, I think it is given as 5 meter per second. So half into 2 into 5 square, 1 plus solid cylinder is given. Solid cylinder is same as that of disk. For disk, k square by r square is 1 by 2. Will be equal to half into 300 into x max square, beta. So what are we going to act in? 2 gaya. 25 into 3 by 2 you will get, which is 75 by 2. Yes or no, everyone? 75 by 2 will be 300 divided by 2 into x max square. So what will I get x max square as, beta? X max square, I'll get it as 75 divided by 300. Okay, so 25 threes and 25, you will get 12s. This will be 1 by 4, beta. So what will x max value be? It will be 1 by 2. Half meter it is. Or I can say it is 0.5 meters, beta. Clear, everyone? Very important question. So as soon as this is the spring in natural position, solid cylinder is rolling and hitting it. So as soon as the solid cylinder rolls, the spring will get compressed. The kinetic energy of the solid cylinder will reduce. Spring will get more compressed. The potential energy will be increasing. So whatever loss in kinetic energy of the cylinder is there, that will show up as gain in elastic potential energy of the spring, guys. Is that clear, everyone? Yes or no, all of you? Hope it is clear. Next question, let us see. A torque of what is given? A torque of 10 Newton meter is applied on a wheel having angular momentum 5 kg meter square per second. I is given, torque is given. If torque is supporting the motion, supporting means angular speed will increase, guys. Then angular momentum of the wheel after 3 seconds they are asking, guys. So in this situation, constant torque is there. So we'll have constant angular acceleration. So I can write torque value will be I into alpha. The torque is given as 10, I value is 5, alpha you will get. So alpha value will be how much, beta? 2 radian per second square. Angular momentum of the wheel after 3 seconds they are saying. So initially let us assume that the wheel is at rest again. So what are we going to write? I can write omega value will be omega naught plus alpha into t. So omega value after 3 seconds I'm finding it, guys. So this will be 0 plus 2 into 3. So after 3 seconds, what is the value of angular speed? It will be 6 radian per second. They're asking us to find out angular momentum, guys. So what I can write, it will be I into omega again. So I value is anyhow 5. This we got it as 6. So we'll get it as 30 kg meter square per second. This will be the angular momentum after how much, beta? 3 seconds. Understood, everyone? I hope you have understood. Next question. Two rings, each of mass capital M and radius R are placed with common center such that their planes are mutually perpendicular. Planes are perpendicular. So let us say if one of the ring is placed in XY plane, the other can be placed in YZ plane, or in you can consider if one of the ring is placed in XZ plane, the other can be placed in YZ plane or XY plane, guys. How are their planes? Perpendicular. They're asking moment of inertia of the system about an axis passing through the center and perpendicular to the plane of one of the ring. So how is the combination here? The combination is like this, guys. Both are identical rings only. So this is one of our ring which is present in which plane? It is present in XZ plane we can take. And how will the other ring be, beta? This you can take it as Y axis. How will the other ring be? The other ring will be present in, let us take it is present in our YZ plane, something like this. Both are identical rings. Now, what they are saying, they're asking us to find moment of inertia about, so about this axis you can take. Is this axis passing through center? Yes, it is passing through their common center, and it is perpendicular to the plane of the second disk, guys. First disk and second disk. They're asking find the moment of inertia of the system about an axis through the center and perpendicular to plane of one of the ring. Okay, so this particular axis, it is x-axis. Will it be perpendicular to YZ plane or not? Yes. So what will you write moment of, how will you write moment of inertia as? Very simple logic. You will take moment of inertia in this situation. It will be sum of moment of inertias for first ring and second ring about the given axis. So the given axis, is it an axis? Is it a diameter for first ring or not? Yes, it is a diameter, guys. Right. So what will be moment of inertia mr square by 2? Whereas the given axis for second ring, is it an axis passing through center and perpendicular to its plane or not? So what is moment of inertia? You'll get it as mr square. So what will be the moment of inertia overall? You'll get it as 3 by 2 mr square, guys. Clear, everyone? Yes or no, all of you? I hope it is clear. Next. A particle of mass 2 kg is projected at an angle of 60 degrees above the horizontal with a speed 20 meter per second. Magnitude of angular momentum of the particle about the point of projection when it is at maximum height. Very, very important question, guys. Right, so I'll take it something like this. We are assuming that there is an object which has been projected with some speed u. In general, I am finding out at a certain angle theta. So can I imagine it to follow a path something like this? It's going to follow parabolic path. Let us imagine. It is projected with speed u. This is the point of projection. Here you have maximum height. At maximum height, you know what will be the speed beta. You will have u cos theta. And when it is point of landing, how will it land again? With whatever speed it is projected, it is going to hit the ground with the same speed. By whatever angle it was being projected, is going to hit by making the same angle. Now they're asking us to find the angular momentum about point O, about the point of projection when it is at maximum height. Okay. So from here to here, what we can consider, this will be our maximum height, but you can take it as h max. So what is angular momentum given as? Angular momentum, we know it is given as r bar cross p bar, right? And as I said, we can write it as r into p perpendicular n cap, or r perpendicular into p n cap, or r p sine theta n cap, guys. Now they're asking us to find angular momentum about which point? About point O. So what will I consider? I'll consider an axis passing through point O beta. We'll consider, just like in order to find out torque, how we did in the same manner. Whenever they're asking us to find out angular momentum about point O, what will we do? We'll consider an axis passing through point O. When it is at maximum height. So at maximum height, velocity is like this. In the direction of velocity, do we have linear momentum or not? Yes. So about whichever point they're asking us to find angular momentum or torque, what will you do? Basic logic. You will consider an axis passing through that point and perpendicular to the plane, guys. You will consider an axis passing through that point as well as perpendicular to the plane. Now you see, at maximum height, right? Axis is passing through point O. Is this the line of action of linear momentum or not? When the object is at the object is at maximum height, this is the line of action of linear momentum. So is there any separation between the axis and line of action of linear momentum? Yes, there is a separation, guys. So if separation is there, it means angular momentum will be there. Now you please tell me, from the axis to the line of action of linear momentum, what is the perpendicular distance? Is this our perpendicular distance or not? So how will I find orbit angular momentum about point O? How much is perpendicular distance? It is h max in which direction? J cap cross. What will be? Let us imagine the mass of the particle happens to be small m, guys. What is the momentum now? I can write the momentum as m into u cos theta I cap, guys. So what is angular momentum about point of projection? It is maximum height. So what is h max value? You know, It is u square sine square theta divided by 2g into m into u cos theta. J cross I will be how much beta? Minus k cap. Right. So what we can write in this situation? Again, it's a very important concept, guys. So I can write it as mu cube sine square theta cos theta divided by 2g minus k cap. So always blindly remember, if they are asking you to find angular momentum about any point, then we are going to consider an axis passing through that point and perpendicular to the plane. If they're asking you to find torque also about any point, we'll consider an axis passing through that point and perpendicular to the plane, guys. And then we will check for calculation of angular momentum, we will check whether the line of action of linear momentum is passing through the axis or not. If line of action of linear momentum is passing through the axis, you will not have angular momentum. In the same manner, we will check for calculation of torque if line of action of force is passing through the axis or not. If it is passing through the axis, there is no separation, so there won't be any torque. This is the general way of solving or calculating torque about any point due to a force or angular momentum about any point due to linear momentum. Understood, all of you? Now you can directly apply in the formulae. So what are we going to get? The angular momentum about point of projection as. What is mass given? 2. What is speed beta? 20 whole cube again. Right? You can write it as sine square 60 cos 60 divided by what? Divided by 2 into 10. So what will you get? Here anyhow you will get it as, I can write it as 2 into 2 cube will be 8, guys. 10 cube, you can write 10 cube again. Sine 60 is root 3 by 2. Sine square 60 will be 3 by 4. Cos 60 will be 1 by 2. Divided by, you will have 2 into 10. So what we can cancel out? 2, 2 gone. 4 ones, 4 twos. This 2 and this 2 also gone. Right. So what are we going to be left out? This 10 and cube will be gone. Square will be there. So our answer should be 300 kg meter square per second, guys. This will be angular momentum about point of projection when the object is at maximum height. Understood, everyone? So or no? Angular momentum will be given as r bar cross p bar, or r into p perpendicular n cap, or r perpendicular into p n cap, guys. Understood, all of you? Yes or no? I hope you have understood. Whenever they are asking you to find either torque or angular momentum about a point, just consider an axis passing through that point and perpendicular to the plane, guys. For calculation of angular momentum, check whether line of action of linear momentum is passing through the axis or not. If it is passing through the axis, there is no separation, no angular momentum. If there is separation, then definitely there will be angular momentum. Same goes with torque. If line of action of force is not passing through the axis, there is torque about the given point. But if line of action of force is passing through the axis, then there is no torque about the given point. I hope it is clear, everyone. Yes or no, all of you? Yes, let us see. It's a wheel starts from rest. Wheel is starting from rest and rotates with a constant angular acceleration. The number of revolutions made by the wheel in 10 seconds they are asking, guys. So what I can apply it is at rest. So what we can write beta? I can use theta value will be omega naught t plus half alpha t square. First I will find angle rotated. So theta value will be 0 anyhow. Half into 2 into 10 square you can get. So what will you get theta values? I'll get it as 100 radian, guys. How much is the angle rotated? 100 radian. In order to calculate number of revolutions, what are we going to do again? Very simple logic. So what is the number of revolutions? In each revolution, how much angle will it rotate? 2 pi angle. The number of revolutions will be angle rotated divided by 2 pi beta. So what is the total angle rotated here? Total angle rotated, we got it as 100 radian divided by 2 pi value will be 6.28 will get or not? So 6 how much? 6 16 will be 96 somewhere. So it will make near about, I think, 6 revolutions, guys. Clear everyone? Sorry, 16 revolutions. 616 ano. Understood all of you? So near about 16 revolutions it is going to make. So from the given value of omega naught and alpha, we'll calculate the angle rotated. So in each rotation or in each revolution, how much is the angle rotated? 2 pi radian. Total angle rotated is 100 radian. So they're asking number of revolutions, which will be approximately 16, guys. Clear everyone? Next question, let us see what they are saying. Two small kids weighing 8 kg and 12 kg are trying to balance a seesaw of total length 3 meters with the fulcrum at center. If one of the kid is sitting at one end, the distance of the other kid from the fulcrum should be how much? So this is again equilibrium concept, guys. Let us consider a seesaw like this. Very important concept. Where is the fulcrum? Exactly at the center. Here is your fulcrum. Okay. Now they are saying one of the kid, if one of the kid is sitting at one end, if one of the kid, first kid or second kid, they have not mentioned. Okay. Two small kids weighing 8 kg and 12 kg are trying to balance a seesaw of total length 3 meters with the fulcrum at the center. If one of the kid, or let us say first kid, is sitting at one end. So let us imagine the 8 kg fellow is sitting here. They're asking at what distance should 12 kg fellow sit, guys, from the fulcrum. So automatically we can consider, uh, in order to balance it, definitely he should sit somewhere over here, let us say. This is what beta 12 kg person. So how much from here to here? What is the distance? X. From here to here, what is the distance beta? Is it L by 2 or not? If total length is L. So what we will do in this situation is we will consider it has to be in equilibrium. Means torque about any point you may take, it should be zero, guys. So torque about F you can consider. So how much should be torque about point F? Torque about point F should be zero. So torque can be due to forces, guys. So what are the forces here? Very simple forces. What are those? One will be weight of 8 kg person. You can write it as 8g. Other will be weight of 12 kg person, which you can write it as 12g. So you can say torque can be due to 8g and torque can be due to 12g. How much should it be? Zero. So whenever you find torque about any point, just now I have told you, we should consider an axis passing through point F. Line of action of 8g is there in this manner. Is there any separation? Yes. So will there be torque? Definitely. Line of action of 12g is passing like this. Is there any separation? Yes. Will there be torque? Yes. So how will you find torque beta? As you are already aware, torque is given as R bar cross F bar. Or I can write R into F perpendicular n cap. Or I can write R perpendicular into F n cap. Or simply I can write RF sine theta n cap, guys. So here, from the axis to the line of action of weight, the perpendicular distance L by 2 or not. So what we can write here, L by 2 minus I cap cross 8g minus j cap plus from the axis to the line of action of 12g. So it is xi cap cross 12g minus j cap. This over should be how much beta? 0. Here, how much are we going to get? Length is given as, I think, 3 by 2. So what we can find out in this situation? Very simple logic. This is 80. 80 by 2 will be 40. 40 into 3 if I take, you will get it as 120. Minus into minus will be plus. I cross j will be k. Plus 120 into x. I cross j is k. I cross minus j will be minus k. Should be equal to what? 0. So I can write 120k. If I send this on the other side, I'll get 120xk. So I can write 120 will be 120 into x. What will I get x value as? I'll get it as 1 meter, guys. Clear, everyone? Did you understand, all of you? Seesaw again. We are using seesaw for balancing, guys, again. Just a game again. Right. So in that situation, what we can take? The torque. They should be in, the system should be in equilibrium. System is in equilibrium means it is both in translation as well as rotational equilibrium. Translation equilibrium means net force should be 0. Rotational equilibrium means net torque about any point you take, guys, in the system should be 0. Understood, all of you? I hope it is clear. Then a uniform cylinder is released from rest from top of an inclined plane of inclination theta and length L. Length is given here. So if cylinder rolls without slipping, speed at the bottom. We know speed at the bottom will be given as how much beta? Root over 2gh divided by 1 plus k square divided by r square. So for a cylinder, how much will be k square by r square? It is a uniform cylinder means disk, guys, 1 by 2. This will get it as 3 by 2. This I will get it as root over 4gh divided by 3. H is not given to us. What is given? Length is given, guys. So what we can use, and theta is given. So I can use sine theta as h by L. So h can be written as L sine theta beta. This will be 4gl sine theta divided by 3. This will be the speed of the cylinder when it reaches the bottom of the incline, guys. Clear, everyone? Next case. If given a cubical block of mass m and edge length L, slides down a rough inclined plane of inclination theta with a uniform velocity. The torque of the normal force on the block about the center of the cube has a magnitude how much? Again, it's a very simple logic, right? If I take an inclined plane beta, whose angle of inclination is how much? Whose angle of inclination you can consider it to be theta. Okay, this is the height of the incline, this is length of the incline, angle of inclination you can take it as theta. So what is happening here? A cube is sliding down a rough inclined plane. So whenever it is sliding down a rough inclined plane, what are the forces? We all know laws of motion, we have studied, guys. So if I take component of forces here, what are we going to get? I'll get one force like this. I'm going to get one force in this manner. What will it be? This you will get it as mg cos theta. It is acting on the incline. You will get one more force in this manner, which is acting along the incline, mg sin theta. So is there some action given by the block on the inclined plane? Yes. Will inclined plane keep quiet? No. What will it give? It will throw normal reaction. From which point? From this point it will throw normal reaction. They're asking us to find what is the torque about the center of the cube. So whenever they're asking us to find torque about any point, what will we do? We'll consider an axis passing through that particular point. They're asking torque due to normal force on the block. So, so if you see the normal force, is it passing through the center? Yes. Is there any separation between the axis as well as the line of action of normal force? No separation means no torque. Okay, so answer should be how much here? 0 should be the answer. Clear, everyone? I hope it is clear, all of you. Let us try to see the next question. What they have given in this question, they are asking us linear mass density. It is a non-uniform object, guys. Rod of length L. So mass is distributed in length here. What is the distance of center of mass from the origin? They are saying one end is at origin. So they have given it something like this, beta. This is our rod. So from the origin, they are asking where is the location of center of mass. So if I assume this point to be 0, 0, automatically the other point will be L, 0. It is a non-uniform rod, guys. So what I will do, in order to calculate this continuous mass distribution also. So in order to find center of mass for continuous mass distribution, what are we going to do? We are first going to consider a small element. Let us imagine that element is at a distance x. And how much is the thickness of the element? Dx. How much is the mass beta? Dm. As I said you, whenever mass is distributed in length, we'll bring into existence a quantity called as linear mass density. For the element, it is given as dm by dx. So I can write dm value as how much beta? Lambda into dx. Because it is continuous mass distribution, how will you calculate location of center of mass? Right, I've told you this, guys. It is integral x dm divided by integral dm. You'll take a small element. So where will center of mass lie for this element? Will it lie here or not? which will be at a distance x only again. So what we can consider, it will be x into, how can I write dm value? Can I write as lambda into dx beta? Yes, divided by integral of lambda into dx. So what are we going to get this as? How much is lambda given? It's 2 plus 3x square, guys. Okay, so if you just solve for this, you'll be getting it something in this manner. So what I'll get now? Here I'll get integral x into 2 plus 3x square dx divided by integral of 2 plus 3x square dx, guys. So I can write it as integral of 2x plus 3x cube dx. What is the variable here? X is the variable beta. Divided by integral of 2 plus 3x square dx. So how should you move the element in such a way that it should start from one end x is equal to 0 to the other end x is equal to L. Here also limits x is equal to 0 to x is equal to L. If you substitute the limits, if you just perform the integration, guys, I'll get x coordinate of center of mass as integral 2x will be 2 into x square by 2 you will get, guys. So 2 into integral x is x square divided by 2 from 0 to L plus 3 into x cube integral will be x power 4 divided by 4 from again 0 to L whole divided by 2 integral will be 2x from 0 to L plus 3 into x square integral will be x cube by 3 from 0 to L. So what are we going to get here? If I substitute 2 into, you will get L square by 2 plus 3 into, you will get L power 4 by 4, right? Whole divided by 2 into L plus 3 into L cube divided by 3 I am going to get. So what we can cancel out? 2 and 2 will get cancelled out, 3 and 3 will get cancelled out. So what will be the L square you will get here? 3L power 4 divided by 4 whole divided by 2L. L is there here. 2L plus L cube. So if I just take the LCM and solve for it, you will get 4L square plus 3L power 4 divided by 8L plus 4L cube. Okay, so if you take in numerator, you can take L square common, guys, and in denominator, you can take 4L common. So if you take L square common here, I'll get 4 plus 3L square. In denominator, you can take 4L common. So you'll get 2 plus L square. So from this, we can L and square will get cancelled out. So what will be x coordinate of center of mass? You will get the x coordinate of center of mass as L by 4, 4 plus 3L square divided by 2 plus L square. This will be the location of center of mass for the given distribution, guys. Here, everyone? Yes or no? You'll get first option as the answer for this. Sorry, third option you'll get as the answer for this. Understood, everyone? Let us see next question, guys. Circular plate of diameter D is kept in contact with a square plate of edge A, as shown in the figure. The thickness and density of materials are same. The center of mass of the composite system, where will it lie? They are saying. Okay, so you can assume this to be the origin, guys. From here, where will it lie? So if I take mass of the first one, guys, let us say density is rho. Mass can be written as density into volume. Here you can take density into area, guys. So m1 will be given as rho into diameter is d, means radius will be d by 2. So I can write pi d square divided by 4. So what will M2 value be beta? Material has density rho you can take and thickness you can take T beta. So what is this? Square is given. Side of square is given as D. So what will area be? D square into T. So as you can look at this, what we can tell regarding M1, can I say M1 will be pi by 4 times of M2 or not? Please tell me what will be C1 center of mass for first one? Center of mass for first one, if I take, if this is the origin, we will write this as minus d by 2 comma 0. What is center of mass for second one? We can write it as plus d by 2 comma 0. They're asking where will be x coordinate of center of mass. So what we can use here, I can write x coordinate of center of mass will be m1x1 plus m2x2, because they can be treated as point masses now. For uniform, regular, geometrical shaped objects, can we concentrate the whole mass at their centers or not, guys? Yes. So what is m1 here? It is pi by 4 times of m2. X1 value is what? Minus d by 2. M2 value is M2 in only, X2 value is d by 2 whole divided by pi by 4 into M2 plus M2 you can write. Okay. What we can take common from this? We can take M2 into d by 2 common in numerator. So if I take M2 into d by 2 common in numerator, I'll get it as minus pi by 4 here plus 1 whole divided by, right? M2 if I take common, I'll get pi by 4 plus 1. So from this we can cancel out. You can cancel out M2 and M2, guys. And what will I, 1 minus pi by 4 you will get, and 1 plus pi by 4 you will get, which I can write it as d by 2 into 1 minus pi by 4 means you will get 4 minus pi divided by 4 whole divided by, you will get it as 4 plus pi divided by 4. So what we can cancel out, 4 and 4 will get cancelled out. So from this, what will x coordinate of center of mass be? It will be d by 2 into 4 minus pi divided by 4 plus pi. So obviously it is a positive value, but 4 minus pi divided by 4 plus pi. Here denominator is greater than numerator, guys. So this value will be usually less than 1. So I'll get xcm value will be less than d by 2. Okay. So it will be towards positive side only, and it will be less than d by 2, guys. Clear all of you? It will be towards right of the origin, you can consider. It will be within the plates only, not outside the plates. It will be towards the right of the origin because we got the value as positive, guys. Understood, everyone? I hope it is clear. Let's see from below, guys, huh? Because there are some questions left. Person is sitting firmly over a rotating chair, has his arms stretched. Initially, he was sitting like this. Now he is stretching it in this manner. Or maybe his arms are stretched initially. And if he is folding his arms, what will happen to moment of inertia? What will happen to moment of inertia? Initially, arms are stretched. Mass is away from the axis of rotation. The moment of inertia is more. Now the arms are folded. Mass is close to the axis of rotation. Moment of inertia will be less, guys. So what is happening to moment of inertia? Decreases. What will happen to angular speed? Increases. What will happen to angular momentum? Will remain constant. What will happen to rotational kinetic energy? I can write it as L square divided by 2I. Yes or no, beta? L is constant, but I is decreasing. So what will happen to rotational kinetic energy? It will be increasing. Clear, everyone? All of you understood or not? Hope you understood. Let us do the question related to rigid body dynamics, guys, again. Okay, so you have a rope is wound over a solid cylinder of mass 3 kg and radius 20 centimeters. A mass of 4 kg suspended from the other end and released. Linear acceleration of 4 kg mass, they are saying. So we just need to draw the free body diagram, guys. If I draw free body diagram of 4 kg mass, what are the forces that are going to act? Firstly, its weight will act 4g or not. What will weight try to do to this point? Weight of the block will try to pull this point downwards. So it is the action applied on the wire, guys. So automatically what will happen? The wire will give the reaction in upward direction. As it is released, it is automatically going to move down. So let us it is accelerating in downward direction. So if I write the translation equation for the block, what will I write, beta? Net force will be equal to 4g minus tension. So net force I can write 4a value will be equal to 4g minus tension. So what will a value be? They are asking us to find acceleration only. So g minus t by 4 you will get. Okay. Now I want to find tension. So did I write the translation of the block? Yes. Now what I am going to do? I am going to do the rotation of the pulley, guys. Does pulley have some mass? Yes, it is mentioned that pulley has some mass, guys. Yes or no? Does it have some mass or not? Yes, it does have mass. So what will I do now? Pulley is fixed. Does it have tendency to translate? No. But it has tendency to rotate about its own point, guys, or about an axis passing through its center. So here, what are the forces that are going to act? Solid cylinder is given. So again, its weight will act or not? Yes. How much is the weight? 3g you can consider. Also, you see what is happening to this point? Because of weight of 4 kg, it is being pulled downwards. So every point will be pulled downwards, guys. So if we talk about this point here, it will also be pulled downwards with a force called as tension. Similarly, it is connected to a string here. So what I'll consider, there will be a force acting, tension acting in this manner. Clear, all of you? Now, pulley is fixed, it cannot translate, but it has tendency to rotate, guys. So in rotation, what is the equation? I'll write torque. Let us say this is point 2. Torque about point 2. It can be due to the forces, guys. So torque can be due to 3g. Torque can be due to tension. Torque can be due to t dash. About which point I am finding torque? About an axis passing through center. So about point 2, if I am finding torque, what will I do? I will consider an axis passing through point 2 and perpendicular to the plane. Now you have forces, three forces. Line of action of weight, is it passing through the axis? Yes, it means there is no separation. No separation means blindly you will say no torque, guys. I want to find torque about point 2. What I'll do? I'll consider an axis passing through point 2. Yes or no, everyone? Now please try to see line of action of weight is passing through the axis. No separation, no torque. Line of action of tension, T dash, is also passing through axis. So no separation, no torque. But if you see line of action of tension T, is there separation? Yes. How much is that separation from the axis to the point? Is this radius or not, guys? The torque about point 2, if I say, it will be R I cap cross T minus J cap. So I'll get torque about point O as T into R. I cross J is K. I cross minus J is minus K. And how can I write torque as bit? I can write I naught into alpha bar will be T into R minus K cap. Alpha bar will be T into R divided by I naught means moment of inertia about point O, guys. So what is direction of alpha? Inwards. When will I get direction as inwards? When the sense of alpha is clockwise. Okay, let us name this point to be P, guys. So what we can tell about alpha direction here? Direction of alpha is inwards. So sense of alpha, how will you get sense of alpha? Sense of alpha will be clockwise, guys. So I can write alpha value as T into R divided by I naught. Implies what will R alpha value be, beta? If I'm multiplying by R on both sides, T into R square divided by I naught. Now please tell me regarding this point. Let us focus on this particular point, guys. Is this point lying on the string? You see, block is moving down with some acceleration A. Now, when block is moving down with acceleration A, will every point on the string also move down with acceleration A or not? So, what is acceleration of point P, beta? A. Okay. Then, because that point P is lying on the string, is the point P also lying on the pulley? Yes, as you can see, point P is also lying on the pulley, guys. Because it is lying on the pulley, what we can consider? Pulley is rotating due to the effect of rotation. What will be acceleration of pulley? It will be R alpha. Both are same points or not? So from this, we can write A value will be equal to R alpha. Clear, all of you guys? So what we can tell regarding R alpha value we already got T into R square by I naught. So can I say R alpha is, so we can write it as T R square divided by I naught. So from this I'll get tension as I naught by R square into A. So what I'll do, I'll take this tension and substitute in this. So what I'm going to get, A value will be G minus, this we got T by 4. So I can write it as I naught by 4 R square into A. So A, if I take common, if I send this on the other side, I'll get 1 plus I naught by 4 R square should be equal to G. So what will acceleration be beta? G whole divided by, I can write 1 plus I naught divided by 4 R square. Clear everyone? So what is I naught value given here? I naught again, solid cylinder is given. Just let us see. Solid cylinder is given. So solid cylinder means I naught value will be mr square divided by 2 guys. And mass of the cylinder is given as 3. So what will I get acceleration here? G divided by 1 plus, this will be mr square by 2. So you will get it as m divided by 8 beta, which is 3 by 8 you will get. Okay, so for acceleration I'm going to get it as 8g divided by 11 we are going to get guys. So acceleration you will get it as 8g divided by 11. Clear everyone? It's a very important question guys. Very, very important question. What will you do here in this situation? Block is translating. You will write the translation equation for the block, right? Pulley is rotating. You will write the rotational equation for the pulley, right? And you will use A is equal to R alpha. These 3 points. There is a easy way of doing the question also. The easy way of doing the question is, now, as this block is going to come down, guys, let us say it is coming down, it is released, right? It will attain some speed. Yes or no? Initially, nothing is there. No kinetic energy for the block, no rotational kinetic energy for the pulley. Conservation of mechanical energy you can do here, guys. Okay. So because only force acting will be weight, because tension will be internal force. There will not be any work done by tension. Only force acting will be gravitational force. We can conserve the mechanical energy of the system. So what will happen? Initially, it is zero total mechanical energy. Now what will happen? As it comes down, kinetic energy of the block will increase, and rotational kinetic energy of the pulley will also be there, guys. So I can say loss in gravitational potential energy will be gain in kinetic energy of the system. That also we can use. Okay. However, it is better to write kinematic equations and solve the question. I hope you understood. Very good question. Very important question, guys. Question, if you see, the ratio of acceleration of the disk of mass m and radius r rolling down an incline without slipping and slipping down the incline. Slipping, instead of saying slipping, guys, it should have been better, it should be sliding down the incline. So in first case, if it is rolling without slipping, pure rolling, what is acceleration beta? You know, it is given as g sine theta divided by 1 plus k square by r square. Whereas if it is simply sliding, it will slide with acceleration what? G sine theta again. Yes or no? If it is sliding without rolling, you can consider it will be sliding with g sine theta. Now, what are they asking? What is the ratio they are saying? So this is in case of pure rolling. This is in case of sliding, guys. Again, I'm assuming it to be, this I am considering it to be on a smooth inclined plane. So what will be the ratio of A1 by A2 they are asking? So if you just resolve this, I'll get it as 1 divided by 1 plus k square by r square. Disk is given. So what is the value of k square by r square? It will be 1 by 2. So I'm going to get overall value as 1 divided by this, you will get it as 3 by 2. So the ratio of accelerations will be equal to 2 is to 3, guys. See, for object to perform pure rolling on a inclined plane, it should definitely be rough, guys. Okay. So here I am assuming the inclined plane to be rough, but while sliding, I am assuming it to be a smooth inclined plane, guys. So answer should be 2 is to 3 for this. Clear, everyone? Understood, all of you? Let's talk about this question. They're asking a force 2I cap plus beta j cap plus 3k cap is acting at a point having position vector. The value of beta for which angular momentum is conserved. When will angular momentum be conserved? For angular momentum to be conserved, can I consider torque should be 0 or not, guys? So what we can write here? For L bar to be constant, what we can consider? Torque should be 0. Torque is 0 means R bar cross F bar should be 0. Space is given, guys. So as I said you, how to find R bar cross F bar, right? If you will take you will take determinant again. So in first row, you will write unit vectors along x, y, and z. First vector is what here? R bar. Second vector is what? F bar. So what are the components of R bar beta here? 8, 6, 12. What are the components of F bar now? You have 2, beta, and 3. How much should torque be? 0. So what I'll do, I'll just take, I want to find x component. Torque is 0 means whether you take x component, y component, z component, you take any component should be 0, guys. If you want to find x component, what will you do? You will block the column and the row in which I cap is present. Or then what are the elements left out? 6 into 3 and this. So what will you get here? You are going to get it as how much beta? I think 18 minus 12 beta, right? This will be how much? I cap. So how much should be x component? 0. In the same manner, you can find out y component also, and you can find out z component also. If torque is 0, it means every component has to be 0 only, guys. So what we can write here? 18 minus 12 into beta should be 0. 12 beta value will be equal to 18, implies beta value will be 18 divided by 12, turns out to be 3 divided by 2. Clear, everyone? Understood, all of you? Right. So for angular momentum to remain conserved, what should be the condition? The torque should be 0. Torque is 0 means you take any component, guys. It should be 0. So I just found out x component. We got 18 minus 2 beta. So 18 minus 2 beta, 12 beta we got. 18 minus 12 beta, you equate it to 0. You'll get the beta value as 3 by 2, guys. Clear, all of you? I hope it is clear, everyone. Let's see this question. A man of 50 kg is one end of a 6-meter long boat of mass 100 kg rests in still water. The man moves to the center of the boat and sits there. The center of mass of the system will shift by, they are asking, guys. So initially, if you see in this case, you can assume boat is somewhere over here. Very direct question. I have already told you, we have done this yesterday, guys. Man initially standing here. Now what he did? This is the entire system. Now whatever is happening within this will be inside the system, guys. Now this fellow, instead of sitting calm, what he is done? He is just trying to move to the other side. So where did he move, beta? He has moved to the center of the boat. So what will happen in this situation? Initially there is no momentum. So while he is moving to the center, it will be something like this. So everything happened inside or not? Yes or no, beta? Right. Due to the internal forces, will there be any? Will it affect the motion of center of mass? Will it affect, guys? Obviously not. So will there be any shift in center of mass? No. Shift in center of mass will be 0. Motion of center of mass will get affected only by external forces. The man moving on the boat or boat moving on the water, they are all happening inside the system. So inside the system, whatever is happening will not affect the motion of center of mass. So there will not be any shift in the center of mass. Initially, wherever center of mass was lying, let us say here, it will continue to lie there itself, guys. Clear? Understood, everyone? Let us see one more question. Consider a gravity-free hall in which a tray of mass m carrying a cubical block of ice of mass small m and edge length L is at rest in the middle. If ice melts, by what distance does the center of mass of the tray and ice system descend? Will it descend? No, guys, it is not going to descend. Why? Because this is the entire system again. If ice is there or ice is getting melted, these are all happening inside, guys. So what is the situation in this situation? There will not be any shift in center of mass. Clear, everyone? Understood, all of you? Is that clear? Or if you just try to solve the question, consider gravity free hall in which gravity free hall they are saying, okay, carrying a cubical block of ice of mass m and edge length L is at rest in the middle. It is initially at rest. So I can calculate center of mass, it will be somewhere over here, guys. Now, even when it is melting, this is entirely happening within the system. Within the system is internal forces. Will internal forces affect the motion of center of mass? No. Initially, center of mass is at some location at rest. Because there is no external force, melting of ice will take place because of its own, guys. With time passes, ice will melt. So what is going to happen in this situation? Center of mass will remain at rest at the same particular point. Clear, all of you? Understood, everyone? Yes or no? There are few more questions again, just like we had some questions left out from electrostatics, just like we had some questions left out in current electricity. In the same way, few questions are there in system of particles that are left out, but majority of the questions which are there in that particular slide also are going to be of the similar models, guys, whatever we have discussed, right? So these were the questions that I thought of discussing, right? We also thought of discussing some more questions, but from time constraint they're not possible. But the questions which I thought of discussing will be on similar model, guys. Okay, so any doubts, all of you? So I hope you have understood all the questions that we have discussed, right? So tomorrow, can you let us quickly decide the timings of the class, and we will end the session, guys. Whether you want to take the class in the morning or in the afternoon, please let me know, please. Because again, tomorrow also you should be writing a test based on gravitation and units and measurement. Tomorrow I have to cover two chapters, which will definitely take around more time, only near about 4 hours of time. I hope so, right? So that is the reason. So I don't know whether we can do heat part, guys, but let us hope that we can do heat part also. Whatever has been given, let us hope that we can complete those things. So tomorrow, what time you want me to take the session, guys? Morning is fine, or afternoon, or evening itself? Let us take rest in the evening, okay? So tomorrow you just tell me in the morning or in the afternoon session, guys. Harshit and Vaishnav, what do you have in the morning? Do you have anything in the morning tomorrow?
No, sir.
Harshit? ठीक है. Maria and Maliha in the morning.
Yes, sir, in morning it is.
क्या है? मॉर्निंग रख सकते हैं क्लास.
हाँ, sir.
ठीक है, तो we can have the session in the morning tomorrow, guys. Okay, clear, all of you? So I'll inform the timings in some time, right?
So would it be after 10:30 or before 10:30?
हाँ, 10:30. Okay,
At 10:30.
maybe here and there before itself, एक बार maybe half an hour or 1 hour before. I'll see if 10:30 possible. 10:30 to 1:30. But I thought of taking in the, because now it's already 10:15. So you may have dinner, or some people maybe have, you might have had your dinner while you are listening to the class, right? So based on that, let us see at whatever time it is possible. I'll just inform. So hopefully somewhere near about 9, 9:30, 10, we will have the session, 3 hour session. If we are completing maximum things by 1 o'clock, then it's fine, right? Or maybe 12:30. Again, if I'm definitely 3 hours in the morning should be taken, guys. If we are not completing, then we may have one more hour in the afternoon, in the evening, not afternoon, but in the evening. Okay. So that's it from my end for today. We'll meet tomorrow, guys. Till then, Take care, everyone. Please, the test has already been shared with you, people, based on work energy, power, and system of particles. Please do write that test before commencement of the class tomorrow. Okay, because tomorrow also again you should write one more test on units and measurements and gravitation. So that's it from my end. We'll meet tomorrow. Till then, take care, everyone. Vaishnav will send the solutions. I forgot actually. I'll send the solutions. Okay. We'll meet tomorrow. Till then, take care, everyone. Thank you all. Bye, all of you.
Thank you, sir.